Hello friends, so here is another question. It is given that the force experienced by a unit charge when placed at a distance of 0.1 meter from the middle of an electric dipole on its axial line is 0.025 Newton. And when that unit charge is placed at a distance of 0.2 meter, the force is reduced to 0.002 Newton. We have to calculate the dipole length. So first let us try to understand the two situations. So here we have an electric dipole. Okay, this is the center. In the first case, okay, this is case 1. The unit charge is placed at this point, which is at a distance of 0.1 meter from the center of the dipole. Okay, this is case 1. This is the axial line. And in case 2, and in this case, the force acting on the unit test charge, okay, positive unit test charge, that is equal to 0.025 Newton. Okay, this is the force. And in the second case, again we have a dipole, same dipole, center here, the axial line, it is placed at a distance of 0.2 meters. The distance is increased. Okay, in this case the force is reduced to 0.002 Newton. Now here we have to understand the force experienced by a unit charge or a unit test charge at any point, okay, unit charge and test charge, that is equal to the electric field intensity at that point, okay, the electric field intensity at that point. Okay, electric field is equal to force by charge, basically the test charge. Okay, and when it is a unit test charge, the force experienced by that is equal to the electric field intensity. Okay, that is equal to the electric field intensity. So in this case we are talking about the electric field intensity. So the electric field intensity along the axial line, the formula for that is equal to the electric field intensity along the axial line, that is equal to 1 by 4 pi epsilon 0 2 px by x square minus a square whole square. Okay, where p is the dipole moment, x is the distance of the point from the midpoint of the dipole. So in this case here x is equal to 0.1 meter, and in this case x is equal to 0.2 meter. The dipole length we have to determine, so a is unknown, and also the dipole moment is not given. Okay, so we have two cases. So for the first case, this axial line electric field, that is equal to the force acting on the unit test charge, okay, unit positive test charge. So here in this case the force is equal to 0.025. So 1 by 4 pi epsilon 0 is equal to 9 into 10 to the power 9 into 2p into x is equal to 0.1 meter by x square minus a square, that is equal to 0.1 square minus a square, this much. This is the first case. And in the second case, for case 2, the force is equal to 0.02 Newton. So again substituting here, 9 into 10 to the power 9 into 2p into 0.2 by 0.2 square minus a square. This is equation 2. Okay, simply we have used this formula. Okay, we have made the substitutions. Now if we divide equation 1 by equation 2, we will get, if we divide equation 1 by equation 2, we will get, okay, 1 by equation 2, 0.025 by 0.02 is equal to 9 into 10 to the power 9 into 2p to 0.1 by 0.1 square minus a square divided by 9 into 10 to the power 9 into 2p into 0.2 by 0.2 square minus a square. So this will become reciprocal, it will get multiplied. So we will have, this will get cancelled, 9 into 10 to the power 9, 9 into 10 to the power 9, that will get cancelled, 2p will get cancelled. So we will be left with 0.1 by 0.2 into 0.2 square minus a square by 0.1 square minus a square. Okay, and this 0.025 by 0.02, that is equal to 25 by 2. Okay, 25 by 2. So how we got it? We simply multiplied here into 1000 and here into 1000, both numerator and denominator we got 25 by 2. Similarly, if we multiply both 10 here, it will be equal to 1 by 2, 0.2 square minus a square. Another important thing, this is square. I have missed a very important thing here. The formula is x square minus a square square. So here it is, okay, it's a slip of mind. Here it is square and here also it is square. Okay, both are squares in the denominator. X square minus a square whole square. Okay, 0.1 square minus a square whole square when x is 0.1, and 0.2 square minus a square whole square when x is 0.2, the two cases. So here there is this square thing I missed. Okay, the square thing. Okay, sorry, a slip of mind. So put that. Okay, so here this is also square, square, and here also it is square. Okay, square by 0.1 square minus a square whole square. Okay, 2 gets cancelled, that implies 25 is equal to 0.2 square minus a square whole square by 0.1 square minus a square whole square. So taking square root on both sides, we get plus 0.2 square minus a square by 0.1 square plus a square is equal to 5. Okay, that implies 5 into 0.1 square minus a square is equal to 0.2 square minus a square. Okay, that implies 5 into 0.01 minus a square is equal to 0.04 minus a square. Okay, this, that implies 0.05 minus 5a square is equal to 0.04 minus a square. That implies 4a square is equal to 0.05 minus 0.04, which is equal to 0.01. That implies a square is equal to 0.01 by 4. That implies a is equal to, it is coming 0.05 meters. That implies dipole length 2a is equal to 0.1 meter. This is the dipole length. Okay, so again I am repeating, here I missed to put the squares. Okay, here I missed to put the squares, so here I have rectified my mistake. Okay, I have put the squares here in the denominator, here. Okay, so then we got the result here. So simple application of the electric field intensity along the axial line. The position of the 2 points changed in these two cases, which led to a difference in the electric field intensity or the force acting on the unit test charge. Okay, so in this way we got the dipole length. We got the value of a first, and then from that we calculated the dipole length, okay, which was asked. Okay,